Hi viewers, welcome to our videos today. In today's video, we are going to be talking about refractive index. Refractive index. So we are going to be looking at the definition of refractive index. We are going to be looking at formulas that you can use to calculate refractive index, and then we are going to be looking at some examples. So we are going to be solving some questions in refractive index. So the refractive index is a fundamental concept in optics that describes how light propagates through different materials. It is a dimensionless quantity that measures the speed of light in vacuum relative to its speed in a given medium. The refractive index is denoted by the symbol N. Now, refractive index, also called index of refraction, is a measure of the bending of a light when passing from one medium into another. Refractive index N, of course, N is the symbol for refractive index of medium 1 with respect to medium 2 can also be represented as subscript N subscript 2 as N1 N2. Okay, so we say that the refractive index N of medium 1 with respect to medium 2 is related to the speed of wave in the two media as follows. Refractive index equal to, well, in medium 1 with respect to medium 2 is equal to the velocity of wave in medium 1 all over the velocity of wave in medium 2. So we can denote this mathematically to be V1 all over V2. Okay, so frequency f of a wave always remains constant during the propagation of wave. So since frequency of a wave is always constant during the refraction, then, and we know from our previous knowledge in wave that velocity is equal to frequency lambda, where that's f lambda, where f stands for frequency and lambda stands for wavelength. Okay, so if velocity is equal to frequency times wavelength, then we can also represent the velocity in medium 1 all over velocity in medium 2 to be equal to f lambda 1 all over f lambda 2. So if f cancels f, then we will now have that the refractive index in medium 1 with respect to medium 2 will now be lambda 1 all over lambda 2. That's wavelength in medium 1 all over wavelength in medium 2. So these three equations, or rather two equations, can be used to calculate the refractive index of a wave when it moves from one medium to the other. Refractive index can also be expressed when we have a refraction, or yes, during refraction as refractive index in medium 1 with respect to medium 2 to be equal to sine of angle of incidence, that's sine I, all over sine of angle of refraction, that's sine R. Okay, so since we have this, it means that practically is we have three equations in which you can use to calculate refractive index. And that the three equation, the equation number one is that V1 all over V2, that's velocity in the one over velocity. And it is also equal to what? The second one, which is lambda 1 all over lambda 2. That's wavelength in medium 1. And it's wavelength in medium 2. And it's also equal to the third one, which is a sine of angle of incident all over sine of angle of refraction. And all these are equal to what? Refractive index in medium 1 with respect to medium 2.